everyone. Today we'll be talking about something that's absolutely critical to any successful AI project, model evaluation, and how to handle unequal error cost effectively. So let's get started. So when training a model, how do I know if it's actually good? So that's where model evaluation comes in. It's like a report card for your model telling you how well it performs based on specific metrics. Like for example, in classification task, we have metrics like accuracy, precision, recall, and F1 score. So for regression tasks, we use metrics like mean squared error or R squared. These metrics give us clear picture of how well our model is doing. So what is model evaluation? So model evaluation is the process of determining how well a machine learning model performs on unseen or test data. It accesses the model ability to generalize its prediction beyond the data it was trained on. So here's the importance of model evaluation. So first is the generalization. It ensures the model performs well on real world data. Then we have comparison, then we have the reliability, and then we have error analysis. So next we have the metrics for evaluation. So for classification models, first we have five metrics, that is accuracy, precision, recall, F1 score, and ROC AUC. So accuracy is the measure that has the measures the percentage of correctly classified samples. Then we have precision, that focuses on positive predictions. Then we have recall, that measures how many actual positives the model correctly identifies. And we have the Evans score, that is the harmonic mean of precision and recall. And then we have ROC AUC, that evaluates the model's ability to distinguish between classes across the classification threshold. Then we have evaluation matrix for regression models. So here we have mean absolute error, mean squared error, root mean square error, and R square, that is coefficient of determination. Then we have the steps for model evaluation. So first we will do the data splitting, that is use techniques like train, split or k-fold cross validation to divide data into training validation and testing data. Then we have the training the model. Then we train the model. To train the model using the training data set, and then we do the test then we test the model. So use the test data sets to generate predictions. Then we evaluate metrics, that compute metrics like accuracy, precision, recall, etc. So now let's look at the code. So here we are performing model evaluation. So first we have to import train test based from sklearn model selection. Then we are importing accuracy score classification report from sklearn matrix. Then we are importing random forest classifier from sklearn assemble. Then we are importing load iris sklearn dataset. So here we are loading the iris dataset. And now next step we will split the dataset, and in next step we will train the model, and then we will evaluate the model based on accuracy and classification report. So now let's run the code. So here we got the output. So first we got the accuracy, that is 1, and then in the classification report we got the precision, recall, and the F1 score and support. And we can see that Python makes it straightforward to train and evaluate models. So this process helps ensure that our model performs well on screen on unseen data. So next we have accounting for unequal cost in Python. So unequal error cost. So, what are error cost? In many applications, some types of error are most costly than the others. Example includes fraud detection, that is, a missing a fraud is costlier than a flagging genuine transaction. Then we have the medical diagnosis. Misdiagnosing a serial illness can have serious consequences compared to a false alarm. So after that we have the approaches to handle unequal error cost. So we have three approaches. First is the custom cost matrix, that assign different weights to penalties to each type of error. Then we have adjust decision threshold, modify the threshold for predicting a positive class based on error cost. Then we have the use weight matrix, that emphasizes costly errors in metrics like weigh, F1 score. In medical diagnosis, misdiagnosing a serious illness can have severe consequences. So now let's take it a step further. Not all errors are created equal. So let me ask you, what's worse, predicting that someone doesn't have a disease when they actually do, or the other way around? So misclarifying critical cases can have serious consequences. That's why we need to account for unequal error cost. So here's the solution code. So first we will import numpy as np, then we will import confusion matrix from sklearn dot matrix, and we will define true labels predictions. Then we use the confusion matrix, and then we define a cost matrix with t and fp, f and tp, that is true negative, false negative, and true positive. Then we will call calculate the total cost. So here let's run the code. Hmm. So here we got the confusion matrix and total cost of errors. So by incorporating the cost of errors, we ensure that the evaluation aligns with real world priorities. In this example, the total cost of errors was calculated based on the defined of the cost matrices. So to sum up, model evaluation is the ultimate test of a machine learning model's reliability and fairness. It ensures the model meets the demands of the real world, whether by handling an equal error cost or by achieving balanced accuracy. So remember, a good model is not just about high accuracy, it's about making the right decisions when it matters the most. And a well evaluated model is the foundation of impactful AI solutions. So thank you. I hope you understood the topic.